Hi, welcome to this video on the modulus argument form of complex numbers. For this video, all you need to know is what a complex number is, how to use trigonometry, and it would be helpful to know what an Argand diagram is, but it's not essential. Let's start off with a complex number z. We will define z as x plus iy, where x and y are some real numbers. They could literally be any number, negative, positive, decimal, integer, rational or irrational, it does not matter. As we know, the real and imaginary parts cannot mix, we therefore can plot them separately like an x and y graph showing the magnitude of the imaginary and real parts. We do this on something called an Argand diagram. We have the real axis represented by RE and the imaginary axis represented by IM. As you can see, I have plotted the point x plus iy on the graph. This point could be anywhere as it is for some arbitrary value x and y. Now say we drew a line from the origin to the point. We will label the angle formed between the line and the RE axis as theta, and we will label the length of the line as the magnitude of z. Theta just represents an angle. It could be anything from 0 to 2 pi. The magnitude of z is just a number as well, and I will show you why it's called this in the next video. With this information we can then work out x and y in terms of the magnitude of z and theta. If we use our trig rules, we can work out what x and y will be. We can work out x as magnitude of z cos theta, because adjacent equals hypotenuse times cos of the angle. And we can work out y as the magnitude of z sine theta, because opposite equals hypotenuse times sine theta. Now we have x and y in terms of the angle theta and the magnitude of z, we can redefine z in terms of theta and the magnitude of z by replacing x and y in our original expression. This gives us a new expression for z as z equals the magnitude of z times cos theta plus I times the magnitude of z sine theta. We can now rearrange to leave us with the form of z equals the magnitude of z all in brackets times cos theta plus I sine theta. This is what we call the modulus argument form, and it may look very useless for the time being, but in future videos we will see just how useful it is, with even applications in integration. Okay, well, thanks for watching. In the next video I will show you how we find the magnitude of z and theta, which isn't as simple as it might seem.